Hi guys, myself Naveen Kumar. I'm going to discuss production engineering today. Basically, I'm going to give a demo on production engineering. So a little bit of intro of me. I've done my BTech from IIT Kharagpur and then followed my MTech in IIT Hyderabad. Both of them are from mechanical engineering and both of them are from manufacturing engineering specializations. And job experience, coming to job experience, I have done as executive trainee in Heavy Engineering Corporation, and that's a PSU in Ranchi. And after quitting my job in Ranchi, then I went on to pursue my PhD in IISc Bangalore. Right now, I'm in fourth year, about to complete my fourth year. And coming to my GATE teaching experience, I have 4 years of experience in different institutes across India. Okay. So coming to syllabus for manufacturing science and engineering and industrial engineering, if you go to syllabus, see the syllabus in GATE portal, section 4 is completely comprising materials, manufacturing and industrial engineering. So all the three materials, manufacturing and industrial engineering are covered by me. So you can see there are lots and lots of topics like engineering materials, casting, forming, joining process, machining and machine tool operations, metrology and inspection, computer-aided manufacturing. All these things comes under materials and manufacturing. So only industrial engineering is left, and that will be in the next slide. So production planning control, inventory control, and operations research are will come under industrial engineering. Okay, so you can see pretty much syllabus to complete, yet it's very easy. So let's move on for the weightage. So if you can see the weightage here, basically you have 100 marks for GATE, and I'm going to cover these two topics, industrial and manufacturing combined. So if you see, there are set wise, class split here. 8 plus 10, 18, 19, these are 21, 20, 20. So you can see here 25 here. So approximately you can say 20 to 25% of the paper is on section 4, that is module 4, and that is materials manufacturing and industrial engineering, right? So there's a huge weightage for materials manufacturing and industrial engineering. Okay, so it's very, very important topic. Please don't skip this topic for your GATE, because now in present trend, you should not skip any topic. You have to complete all the topics in giving equal weightage to each and every topic. Okay, fine. So moving on, let's define manufacturing. Manufacturing in broadest sense is the process of converting raw material into valued products. Okay, so you can see here converting raw material into valued products. So let's see what is how this manufacturing process are utilized for converting raw material into valued product. Before that, let us see one cycle of a product. What you do, so you take raw material from the earth. This is your raw material, you take it from earth. Then as it is in crude form, you can't use it, you process it. Then you process it. After processing it, then you use it for making an object by using manufacturing process. After manufacturing, you get a product out of it. And after product, you won't directly use it, you inspect it. You will do the inspection whether the product is manufactured or produced up to the mark. So if in inspection, if there are no defects, then you can directly use it. Or if there are any defects, if you found any faults in the product, then it means that either you have some problem with the material processing or you have problem with the manufacturing process. So the defects will make sure that you can have a feedback into the material processing section and manufacturing section. By correcting the feedback, you can make the product, and it's a cycle. So this is how you convert your raw material into a valued product with the use of manufacturing. Okay, so that is called manufacturing in product sense is process of converting raw material into valued product. Okay, here also you can see the input here is raw material, and okay, and if you see the process or manufacturing process, the way to manufacture them, and output is the output product that you're getting. So from input to output, you're giving some value addition. So this is your final product that you're going to get from this value addition manufacturing. Okay, so what are the steps that are included in this? So what are the steps that are included in manufacturing processes? First step, anyways, you have to design the product. Obviously, if you have any requirement, let's say if you want to prepare a chair, so first you have to design the chair, and then you have to select appropriate material for the chair or the product, and then you are not going to manufacture in the random sequence. There is a specified sequence in which the manufacturing processes have to be made or done so that the product will be coming out as output. Okay, so you can see the sequence of the process through which the product will be manufactured. So you can see here how, let's say if you have a bolt, this is a bolt here. So if you have a bolt, so the sequence can be, you have a casting billet first, and then I think you have to use a turning machine to make the diameter come down. Then maybe you use a milling machine to make the bolt head, and after that again you have to use some threading to make the threads for the bolt, so on. There are so many other processes. So these are the sequence of the processes that you have to maintain for making any product in a very good manner. Okay, moving on. So we have some broader classifications. Obviously you can see the syllabus of mechanical engineers here. So broader categories are casting, that are again classified into expandable molds and permanent molds. So let us discuss this in coming slides. What is the difference between expandable molds and permanent molds? Then the next procedure or category is forming or shaping. In forming, again we can classify into if your raw material is in solid state, and if you are using the forming and shaping, then the processes are known as forging, rolling, extrusion, drawing, sheet metal operations, etc. All these are there in our GATE syllabus, and we are going to discuss these things in detail. And the second thing is in liquid and semi-liquid. If your raw material is in liquid or semi-liquid state, then that is called casting or injection mold. Okay, casting already we have seen here, so it's a casting procedure. So next, if the raw material can be simply in powder form, here it is solid, here it is liquid and semi-liquid, and it can be in the form of powder also. And if you are using powder form for the raw material and you are manufacturing a product, and that is called powder metallurgical process. So we are going to discuss this also. This is also included in GATE syllabus. And the next classification is machining. And obviously, you know, in any manufacturing plant or section, it is very, very important that you know machining process. And it's a subtractive manufacturing process. Subtractive. So let me write here, subtractive manufacturing process. So you remove the material and manufacture a product. So you contain that contains turning operation, milling operation, boring, drilling, planning, shaping, broaching, grinding. So till here you have conventional manufacturing process. After that we have from here to here we have non-traditional manufacturing. It's called non-traditional or unconventional traditional manufacturing process. So these are conventional, these are non-conventional or non-traditional. So in the coming slides or in the coming lectures, let's discuss why these are called conventional and why these are called non-traditional or unconventional process. Okay, you can have ultrasonic machining, chemical machining, electric discharge machining, electrochemical machining. In under high energy beam machining, you have laser beam machining, electron beam machining. Everything comes under laser beam machining. Electron beam machining comes under high energy beam machining. The next classification we have here is joining process. Those are welding, brazing, and soldering. So we are going to discuss these things also in detail. So what is the difference between a brazing procedure and a soldering procedure? And then the last and recent classification is regenerative process. Till now we have seen subtractive and shaping. We have joining process, like you are joining two materials. You're joining two materials using welding. Okay, and by using shaping or forming, what you do, you take a material and you convert that into a different shape by using shaping or forming procedure. And casting, you convert a raw material and liquefy the material and make into some shape by pouring a liquid metal. And machining is a subtractive manufacturing. You have a material, then you slowly remove the material, and finally you get a product of different size and shape. So you remove material from here by using a single or multi-point cutting tools. And regenerative process is recent, that is add material in layer by layer. So you can see production of solid products in layer from raw materials in different form. So if you have a product, something like this, so what you do it layer by layer. So you can see here, you can do it layer by layer. Add them layer by layer. So layers. So I think if you already know, there are so many regenerative processes. Those are selective sintering, fused deposition models. This all comes under additive manufacturing. Additive manufacturing. Sometimes it is also known as, I think you already know this, that is rapid prototyping. Okay, so I think this section is not there for gate, but anyways, we'll have some overview of this. Next, so coming to the first classification here is metal casting. So in metal casting, what is the metal casting process? Already know that it's a process of pouring metal into a hollow cavity and allowing it to cool and solidify into a desired shape. Here you can see some terms here: molten metal, pouring, hollow cavity, and cool, solidify. So first you create some molten metal by using some metallurgical process, and then you create a hollow cavity by using some molding techniques, and then this you pour this into your hollow cavity and allow it to cool. Then it will get solidified, then you get a desired shape. This solidified part that you are getting after cooling and solidification is called a casting. Called a casting. So we have seen the broader classification in the previous slide, that is permanent mold and sand mold. Permanent mold is made up of steel materials, here steel or something else, and expendable molds are of sand molds. Sand molds. Okay. So this can be reused again and again. This cannot be reused. You have to discard this mold cavity and then you have to form the cavity again. These are reusable. These are not reusable. Not reusable. Okay. So what are the industries that are concentrating on this metal casting procedures? Those are automotive industries, cookery, cooking items, aerospace industries, railroad, jewelry, etc. So if you go to a manufacturing plant, I think you might have visited, you can see a section called foundry section or foundry section. So this is the place where this casting procedures are conducted. Okay, next. So, sorry. What are the steps that are involved for a metal casting process? Number one, you are making the mold cavity. As I told you, you have to make the mold cavity. This mold cavity is made by using a thing called pattern. So let's discuss that pattern little later, but we have to use a pattern to make this mold cavity. Pattern, you can call pattern as a replica of mold cavity. Replica of mold cavity. Then you take a material that is suitable and then you liquefy by using some heating procedure in a furnace, and take that liquid material, you pour that into a liquid mold cavity and then allow it to solidify, and then take the mold cavity product is taken out of the mold cavity and then trim because you have some extra portions, and then taking into a shape, and this is your product, which might be a final product or not, you don't know. Final may not be final also. Final means this can be directly used in your application. May not be final means you have to make some other procedures or processes. You have to use some other manufacturing processes on that product to make into a valued product. Okay. So I think these steps are already discussed in the previous slides. And so basically, what are the things that we have to concentrate on casting procedures so that you get a successful casting? The first thing you can see here is preparation of molds of patterns. So pattern, I already told you, pattern is the replica of mold cavity. What is a pattern? Let's say you have a mold cavity. Let's say you want to make a object like this. Then what you do, you take a pattern of same size and shape. This is a replica. This is made up of some other material. Let us say it is wood. You put this wood here, then you put some sand in, and then you remove the replica, and then you pour some material and solidify, and you get an object. Okay, so this procedure I'll be discussing in detail in the next slides. So you melt, pour into the liquid metal into the cavity, then solidification, and then you inspect for the defects. And then if it is a defect-free casting, then you go for use. If it is having some defects, you reject them based on the severity, and then you find out why these defects are occurring, and then go back to the origin where the problem has started, and you rectify them, and you start doing the castings. Okay, next. So what are the advantages of casting? So you can make a very complicated shapes by using the casting. Let's say you have some engine block. So engine block of any machine or any automobile have very complicated parts in it. Very complicated parts. This engine block, the outer part of engine block can be completely manufactured in one go by using this metal casting. Okay, so highly complicated shapes can be manufactured by using metal casting, and the procedure is very less expensive procedure. Very less expensive means you can use the mold cavity again and again, that is your permanent molds, to make a mass production. To make mass production, so it is very less expensive. The initial cost might be a little high. As you keep on use for mass production, the expenses are coming down. Ductile and brittle material, both the material can be produced in casting. So any other different procedures cannot be used to make both the materials, right? Because ductile and brittle are different in their own senses. Ductile material is soft, brittle materials are very hard. So soft and hard materials, both of the properties materials can be made by using metal casting, and large size objects can be made up to 200 tons in a single go. In a single go, you can make this large size object by using metal casting. So as you have some goods, you have some bads also. Bads are casting objects are not having smooth surface finish, because as you're putting into the mold cavity, this is your cavity here. As you're putting in cavity, this cavity is having some wall here. So because of this wall, your molten metal is coming in contact and your mold material is coming into contact. Because of the interaction between these two, your surface might not be good enough. So you have to have some surface finish operations to use that object at the final bed. Next, it is very labor intensive. Go and see, there are huge amount of labors and incorporated for the casting procedure. Automation is automation of this process is still a question mark. Still a question mark in nowadays also. What are the possibilities of defects? So there are so many possibilities. So casting is not a defect-free process. There are so many defects in it. So we will try to minimize the defects and make sure that casting is used at the final without any severity problems. The next is you have non-uniform mechanical properties. So you can't get a single mechanical property in single casting. You have so many different properties in one casting because of the non-uniform cooling. So we can discuss this in the further lectures. Why this? What is this non-uniform cooling? And because of this non-uniform cooling, why we are getting non-uniform mechanical properties and all, we're going to discuss in the next lecture. So coming and seeing, you have, this is a green sand casting. You can see here green sand casting. So you can see here there are a bottom board that you have. On bottom board you keep a box that is called drag. The bottom box is called drag box, and the top box is called co. You can see, and then this is the pattern that you're putting here, and then this is the riser, this is screw, this is pouring basin, and all. This is everything. So what will happen is you pour the material into the pouring basin, then it is traveling through the runner. It is called runner here, and right here it is runner. and it is passing through gate, it is passing through in gate, and it is entering into the mold cavity because this pattern is removed, and then it will come and rise through the riser. Okay, so this is how the metal is flowed into the thing. The useful part is only here, and these are all called gating elements, but these are very much important for our casting procedures. So basically you can see the pouring basin is metering device for the flow of metal. So how much material you're pouring is measured by using this pouring basin. And then you have a screw. Sorry, this is not a runner, it's a screw. I'm sorry here. This is not a runner. It is a runner is this. So this is a screw and this is runner. So it is basically main feed into the mold. So you're putting it into the screw. This screw is used to avoid aspiration effect. So we'll discuss what is this aspiration effect. Don't worry about it. Aspiration. Aspiration effect means to avoid gas bubbles into the casting. If you use screw properly, you can avoid gas bubbles into the casting because gas bubbles are the defects in casting. Then you have choke, then you have runner because it passes, it's a passageway through the mold because it's a passageway through the mold cavity and the screw. Then you have gate system. The entry part here is called gate, and then mold cavity. You have mold cavity here, and then riser. This riser is used to make sure that it will reduce, mitigate means reduce the shrinkage. Because if you are pouring some metal into it, obviously after cooling down, it will shrink. So to make sure to provide sufficient amount of molten metal into the cavity, we are using the riser. Okay, so that's it, friends. This is the basic lecture on introduction of manufacturing process and a little bit of introduction of metal casting, and following through a slight introduction of grain sand casting. Thank you.